Exercise 6.4, Newton's first law, question 1. A girl is standing in a moving train and she's facing the front of the train. To explain where the girl would land when she jumps vertically up in the aisle. Okay, so for this, okay, to set the context, what we have over here is a train, okay, that is moving in a certain direction. Now the girl in the train will also be moving with the same velocity as the train. Okay, and then she decides to jump up and come back down. Okay, we're going to compare a point on the train and the motion of the girl to see whether she lands on the same point, in front of that point, or behind that point. Okay, so before we talk more about this question, okay, let's watch a short demonstration. Okay, I'll share the link below. So this is a very interesting demonstration where we have a medicine ball being thrown upwards, okay, from a moving truck. So because the medicine ball was originally on the truck already, so it'll be moving with the same horizontal velocity as the truck. Okay, let's take a look. So our question is, will it come back down or in front or behind? Okay, what will it be? Okay, so you can see it lands back onto the thrower's hand. Okay, now let's watch this video again. Okay, but this time around we focus on the relative motion of the ball to the thrower. Okay, so notice that it's moving at the same horizontal velocity as the truck that is moving at constant velocity. So because both the ball and the truck are moving at the same horizontal velocity, therefore the ball returns to the thrower's hand. And what happens if the truck is accelerating when the ball is not? Okay, so this demonstration, there are actually two parts to it. The first part, the cart is just going to go towards the right at a constant velocity. So when the launcher launches the ball in the upward direction, notice that it's going to go up and come down and go back into the cart. Okay, second part of the demonstration, okay, the cart is going to be attached to a string, okay, which is attached to a mesh over a pulley. So because of the mesh, right, the cart is going to be accelerating. Okay, and notice what happened.
Demonstration as we did with the regular cart, except the tunnel makes it a little more impressive. So here we go.
This is constant velocity. The ball goes back into the cart.
The smart ballistic cart catches the ball when they both have the same motion along the track.
Notice a string over here.
Previously, they had the same horizontal speed. They also both had zero acceleration. So now I'm going to change that.
Now there's acceleration.
Smart cart going over a pulley attached to a weight. And so the smart cart and the smart ballistic cart accessory will accelerate along the track. But when the ball gets launched, the ball will stop accelerating in the horizontal direction. It will have a different acceleration, and we'll see something different happen. So that was it.
Okay, so bottom line is, if both are moving at the same velocity, okay, the ball returns to the cart. If the cart accelerates, okay, when the ball is still moving at the same constant horizontal velocity, then the ball gets left behind. Okay, so now the girl over here is just like the ball, okay, in the demonstrations. Okay, and the train here is like the cart or the truck. Okay, so when the train continues to move at constant velocity, what happens is the girl who jumps up, okay, she is going to move with the initial horizontal velocity of the train, right? So if the train itself moves at the same horizontal velocity, then we expect the girl to land back, okay, on point P. Okay. However, if the girl, when she jumps up and is moving at a constant horizontal velocity, okay, if the train now is moving with a positive acceleration, then we expect the velocity of the train to be higher than that of the girl. In other words, point P will move further, okay, as compared to the girl. Okay, maybe she moved up to this point, okay, but point P has moved further, right? Therefore, she should land behind. Okay. In the third case, the girl is moving at a certain constant horizontal velocity, okay, and this time round, the train slows down. Okay, so the girl is then going to move further horizontal distance as compared to point P, right? So maybe the girl still moves so much, okay, but now point P only moves this much. So I expect her to land in front of point P.